Welcome back to 7th grade Math Algebra, Unit 1, Lesson 4. Today we're going to be working with solving algebraic equations. So a quick materials check, make sure you're set up for today. You should have a piece of paper or notebook to take notes in, your classwork on Google Classrooms, your pencil, and then a calculator. Then set up your notebook to make sure that it matches what you have here, which is the date, Unit 1, Lesson 4, and then the lesson title, which is Solving Algebraic Equations. Take 30 seconds to set yourself up for class. Okay, let's talk about how today's lesson connects to what we've been working with. So yesterday we learned how to model problems using equations where at times there were variables on both sides of the equation. So to take an example from your classwork, you have this problem. Robbie and Yesenia are both saving money. Robbie starts with $60 and is saving $7 per week. Yesenia starts with $120 and is saving $5 per week. How long will it take for both of them to have the same amount of money? And to model this problem, you should have written the following equation. 60 plus 7w equals 120 plus 5w. Notice that there are variables on both sides of that equation. So far in math this year, you guys have actually already done a lot of work when it comes to solving equations with variables on one side of the equation. So for example, here's a common problem that you might have seen. 3x minus 21 equals 24. Using inverse operations here, adding 21 to both sides, dividing by 3 to get a final answer of x equals 15. So this is what we've already done. And then today, we're going to be learning how to solve equations that have variables on both sides of the equations. So similar to this example with Robbie and Yesenia, we're going to actually learn how to be able to solve those equations. All right, our driving question for today is, how do we solve equations with variables on both sides of the equation? And before we jump into that, let's think about why this is actually helpful. So I want you to imagine a scenario. I'm about to do some art, and I have my paint palette ready to go. But tricky part is I'm blindfolded, all right? So I'm selecting colors right now with a blindfold on. I select a little bit of an unknown color, right? And I put it on an empty place in my palette. And then same thing, I take a second unknown color and I put it in the same place of my palette, and I start mixing those two together. All right, and I was blindfolded when I chose both of those colors. Now I'm taking the blindfold off and I see that the color I've made by mixing those two together is green. So I want you to chat this to your teacher. What do you think the unknown colors that I mixed together were? Chat the response now to your teacher. Your teacher's going to pause the video to give you time to do that now. Go ahead and pause. All right, likely you guys said that the two colors must have been yellow and blue. Now the question is, how did you know that, right? So we know that the color green can be made by mixing together the two colors, yellow and blue. And that's because there's a particular type of relationship between those two colors that creates green, okay? So we know something about the relationship of those two things, and we were able to figure out what those colors were from making the green, even though we originally didn't know what we started with. And that leads us to the first really big idea for today, which is super important, which is if we know the relationship between multiple unknowns, we can use it to solve for them. So in this example, we knew the relationship of those two colors to one another because we knew what color they made, and we were able to deduce from the color they made, which was green, what the two colors we started with must have been. Okay, make sure you have this down in your notes. All right, let's preview our agenda for today. So far, we've talked already about how this lesson connects to our earlier lessons, and we've answered this question about how can the relationship between two unknowns help us solve for them with that paint example. Next up, we're going to jump into a vocabulary preview. Then we're going to investigate our driving question. How do we solve equations with variables on both sides of the equation? And lastly, we're going to get some time to practice. So let's jump into that vocabulary preview. At the top, you can see some of the terms that we've actually already discussed, so you don't need to write those down again. In yellow highlighted, you see some of the new terms that we're going to be incorporating today. The first one is solution, which is a value of a variable that makes an equation true. So for example, taking the equation you see here, 3x plus 5 equals 32. When I solve that, I get a solution of x equals 9. The second term is inverse operations. And inverse operations are operations that undo what was done by a previous operation. So for example, if I subtracted 2, the inverse operation would be to add 2. If I multiplied by 5, the inverse operation would be to divide by 5. Lastly, you have constant, which is a term or expression with no variable. So some examples of that are -12 or 25. Okay, now that we have the vocabulary, we're going to move on to the actual content, right? And so I'm going to model how is it that we actually solve an equation that has variables on both sides, okay? So consider the following problem. Determine the solution to the equation 2 times the quantity 1 plus n equal to 4 minus 3 times the quantity 5n minus 8. And pick the equation below that has the same solution. All right. I'm going to focus on that first part of the problem, which is just solving, okay? So here's my equation. Now I'm thinking back to everything we've learned this year, and I know that one of the first things I'm going to need to do is actually simplify this equation so I can start to work with it, okay? So I'm going to go ahead and I'm going to distribute the 2 and the -3 to both of the terms inside of each of the parentheses, okay? And that's going to lead me to 2 plus 2n on the left-hand side is equal to 4 minus 15n plus 24 on the right-hand side. And notice here that it was important for me to distribute the negative sign on the 3 to both the 5n and also the -8, okay? Now that I've distributed, I'm gonna go ahead and rewrite this and reorganize my terms a little bit. I'm gonna do this so that I can put together like terms. So next I can write 2 plus 2n equals 4 plus 24 minus 15n. This is going to allow me now to actually combine my like terms. I can't do anything on the left, but on the right I can combine those two constants. So now I have 2 plus 2n equals 28 minus 15n. All right, that's looking a little bit better. Now I need to solve still. So I think what I'm going to try and do here is I'm actually going to try and get all my variables on one side of the equation and all my constants on the other side of the equation. So let me start with those variables. I'm going to move them all to the left side of the equation. And to do that, I'm going to add 15n to both sides. That's going to give me 17n plus 2 equals 28. Now that I have all my variables on the left, I want to move my constants to the right. So I'm going to go ahead and I'm going to move my constants over to the right-hand side of my equation by subtracting 2 from both sides. That's going to give me 17n equals 26. I'm almost there. In order to solve this, I just have to divide. So I'm going to divide both sides by 17. And that's going to lead me to my final answer here of n equals 26/17. All right. So quick vocab check here. What do we call 26/17? Raise your virtual hand to answer. Think back to the vocabulary words that we previewed. Your teacher's going to pause the video to call on someone. Go ahead and pause the video now. And hopefully you answered solution, which would be correct. N equals 26/17 is the solution to this equation. All right, so let's just zoom out a little bit so that we're super clear on the steps I took. My first set of steps is highlighted in blue. And in these sets of steps, I was simplifying the expressions on both sides of the equation by distributing and combining like terms. Next up, you see the second set of steps I took in green. In this set of steps, I was using inverse operations to get the variables to one side of the equation and the constants to the other side of the equation. And then lastly, in purple, you see my final steps, which were to use inverse operations to solve for the value of the variable, okay? Which gives us our solution. All right, this leads us to our key point for today, which is actually pretty intuitive because it really connects to a lot we've already been doing, which is that solving equations that have variables on both sides actually isn't different from solving an equation with variables on one side. Inverse operations are used to isolate a variable to solve an equation. That's true regardless of whether there's variables on one side of the equation or both sides of the equation, like we just saw. So go ahead and make sure you have that down in your notes as we move forward. All right, we solved the first part of this problem, but we still have to do the second part that I highlighted here, which is pick the equation below that has the same solution. Well, option 1 here, I could solve each of the equations to determine which one also has a solution of 26/17, but that's going to take a really, really long time. Is there an option 2? What do you think? If you see a simpler or faster option, type it into the chat now. Your teacher is going to pause the video to give you time to do this. Go ahead and pause the video now. And I'm guessing one of you said that it'd be a lot faster to determine if you can find the equivalent equation by just looking back at your work, right? And not actually solving each of these answer choices. So let me look back at my work. Let me focus in on this step here where I had the expressions on either side of the equation simplified, right? So I had 2 plus 2n equals 28 minus 15n. Now let me take that and let me rearrange it a little so that I have the variable now coming first. So I have 2n plus 2 equals negative 15n plus 28. And now if I look at my answer choices, I can actually see that A has got to be the correct answer, right? And I was able to find that without solving every single one of these answer choices. Now, this is really, really important because you're going to be taking really big tests coming up in your future, like the SATs and the Regents. And oftentimes they're going to include problems like this, right? Where there's one way that takes a lot longer and can lead you to the correct answer. But there's a second way that leads you to the correct answer and is much, much faster, all right? And as mathematicians, we want to keep in mind that we should be looking for the most efficient pathways to solve problems whenever possible. Okay, make sure you have this down in your notes. All right, now it's your turn. Here you go, here's your problem. Solve the equation 8 times the quantity 1 minus 5x plus 5 equals negative 77 plus 5x. You have the next 3 minutes. Your teacher is going to pause the video. You're going to type your response now for question 1 in your classwork on Google Classrooms, okay? Go ahead and pause the video now and answer question 1 for the opening video question. All right, welcome back. Let's debrief the correct work for this problem. All right, so here's my equation. The first thing I'm going to do is distribute, right? So now I have 8 minus 40x plus 5 equals negative 77 plus 5x. Next up, what I'm going to do is I'm going to rewrite so that my like terms are near each other. 8 plus 5 minus 40x equals negative 77 plus 5x. Now I'm going to combine like terms. 13 minus 40x equals negative 77 plus 5x. So now everything's as in simplest terms, right? The expressions on both sides are good to go. And I need to think about how I can get all the variables to one side of the equation and all the constants to the other. So I'm going to start with the variables, and I'm going to add 40x to each side. This gives me 13 equals negative 77 plus 45x. Now I got to work with the constants, so I'm going to move them to the left-hand side by adding 77 to each side. Now I have 90 equals 45x. Last step to solve here, I'm going to use inverse operations, divide by 45 on both sides, and my solution is x equals 2. Just to recap the steps we took, because they're going to be the same every time. In this blue box, you can see the steps for where we were simplifying the expressions on both sides of the equation. In this green box, you can see where we were using inverse operations to get the variables onto one side and to get the constants onto the other. And then in this purple box, the last one, you can see how we used inverse operations to solve for the value of the variable. Okay? All right, you're going to jump into some practice. Remember, you can always reference this as you practice. You're going to be working on classwork problems 1 through 7, and then 2 problems for your exit ticket. Good luck, and I hope you all have an awesome rest of your day.